Hey everybody, welcome to today's training. This is TJ with ShopBot Tools, and today's online training is going to talk about two-sided 3D carving. So what we'll do is we'll first look at our file here, and then we'll go out on our machine and show you the process of trying to flip this part over so it lines back up so we can cut it from both faces of this material. After we get the design portion ready in the software, what we'll do here is cut it from the first side. Use our layout holes where we use 3/8 dowel pins, drill those in, switch the board back, do the same dowel pins in the spoil board, flip it directly over on top of itself, lining up using the dowel pins, and then cutting the second side. Hence the two-sided 3D machining. A good portion of this training will be using the Vetrix software, and I will tell you that a lot of the information that I am using comes straight from their video tutorial browser. They already have a wonderful set of videos and tutorials, and I'm referencing today a lot. When I first started getting into doing the two-sided carving was this two-sided marlin, where I could go in here and watch the different tutorial on all the specifics to the Vetrix software. So I'm going to cover a lot of these today as well, but I'm going to show you more tips and tricks for setting this up on the actual ShopBot. So I'm going to create the new file, and today's job is, as you saw in the example, I just did this. I went and got a 2x6 from Lowe's or Home Depot. It's something easy to practice on. So it's something that if you make a mistake, you forget your tabs, you hold down, you flip the wrong way. It's out of a piece of 2x6 pine. It's not the most expensive wood. And then once you get the system down, you've done it a few times, then it's nice to go into something a little nicer quality wood as far as the way it's going to turn out. So let's just go through, and again, I'm going to paraphrase a lot of that tutorial. It is a double-sided machining because we're going to be cutting from two faces. The material I have here is 2 foot long. It's a 2x6, so it measures approximately 5.5 inches wide, and the thickness on that material is 1.5. The way I like to set up a two-sided machining, again, there is no right or wrong. It's all personal preference. And this is just what I've done for a few of my two-sided machinings and had success, so I'm sharing that with you today. The material surface is where I like to zero, but I also like this option that Vectric has put in here where you zero off the same side. So what that allows me to do is on the first face, I zero off the top. And then when I flip it, I'm able to zero off that same top even though it's down below. So I'll actually be zeroing to the machine bed next. The software takes into account the flip and does all the math for you. The key though is the XY datum position and moving that to 0, 0. That way your flip plane, whether you're flipping along the X or along the Y, and in this case I'm going to flip over across the Y. So what's nice about having your XY datum position in the middle, it gives you a plane here that's easier to flip. And what's nice about that is whatever your job size here, if you're off a little bit as far as width and height, this helps take that into account with your 0, 0 in the middle. So with that being said, I'm just going to double check this. I got my material size. I've cut it down to 24 inches. It's just a 2x6. In inches, I have a 0 plane on the top with a flip, 0 off the same side, and I'm going to go ahead and hit OK, and that sets up my job. I just need to remember which direction I'm flipping between sides. Now we have to import the model, and the way we do that is come down here to the modeling tab, and up here is import component or 3D model. And today's example is going to be using a two-sided propeller, so I'll bring in the prop file. And a lot of imported 3D files come in a lot larger. Here's my material down here. This solid line box is my material. This wireframe box here is my material. My propeller is obviously quite large and out of proportion and orientation. So I will just sit here and manipulate the way I want to bring this in, which face I want to bring it in from. And that's just a matter of me messing with this model, and this is exactly what you would have to do as you brought stuff in. I'm going to center that on my material. It hides it down in there. And since my material is only 24 inches long, I'd like it to only be about a 20-inch long prop. I hit apply. I can see that it's on there still, but it's still really close to the edge. I want to look at this straight from the top, my Z, and I can interactively rotate this too by clicking on my Z, and that allows me to spin the propeller and get it straight back and forth so it's in there. So I've scaled it. I've got it flat, the direction I want. That's just a matter of you playing with the model that it is that you're going to bring in. I do want to create both sides. I do want it centered. I do like to center my models when they're proportional like this. Otherwise, you can mess with the up and down direction here, but it is nice to double click here, keep this centered. And then I do like to have an overcut that goes at least past, at least I'm going to use a 1/4 inch diameter ball nose, and really you only need to go the radius of that bit, so you get past what they call the cusping, and that helps you get past where that ball nose portion of it is. I tend to do a little bit more dramatic with my overcut, and that gets a little bit more past, if I was off on my material thickness or whatever. So I just leave this right at my bit diameter. It just helps me remember things too. So overcut, create both sides, and I've got it now in my model inside my wireframe. I'm going to go ahead and hit OK, and we're ready to move forward and set this model up. Set this up just like we did in the VCarve Pro. So first thing we're going to do is hold down our board, and I'm just eyeballing it off the bottom left corner, even though that's not where we're going to 0 it. And I pre-drilled the corners, and I'm opening up my ShopBot software, and I'm going to 0 out my X and my Y axes first. So use the proximity switches so you're working off your bottom left corner. That way you've got a reference in case you ever lose power or you have to reset or anything. You do have that. So we'll start there. It sets us up, goes over, goes off 0. Now remember, in the drawing CAD file, we're using the center of our material, which is where the X is. So now I'm going to use the keypad in the software to eyeball that and get it close. So bring up the keypad, go back and forth until you get it in the X and Y. You can switch it to fixed mode. Fixed mode allows you to dial it in so you can get it real close. You can also 0 your Z axes right now and just get it down until it touches. And then you can temporarily make your new 0, 0. So what we're doing is we're making a temporary 0, 0. So this is new to you. You might want to look in temporary zeros and offsets. Maybe look into the documentation or training. But what I'm looking to do here is I want to make this center of my bit my new 0, 0 point. And I zeroed it off the proximity switches first because that's how far I just moved it over in the X and in the Y. And I have those as reference numbers in case I have to reset my computer or I lose power or anything. So, but I am clicking on my X and my Y, and I'm zeroing them out right now, and I've made my temporary 0 to run this file. So in the Vetrix software, again, looking at the two-sided machining, if this is your first time, again, I would really recommend looking at some of the other tutorials. But for you first timers that are watching this one, I would see up here is where you can switch between your top and your bottom plane. You can see it changing here. If you have both your 2D and your 3D forward, when you click between, you can see this scale gets browned out when it's on the bottom. And you see the arrows also when it switches between the top of the two. And over here, and again under your modeling tab, you have your limit planes. And you can always go in here to your properties and see where they're at with the different, again, if you're going to be doing more of understanding how does 3D modeling work, and in essence you've never done it before, I would go back to the Vectric tutorial. What I want to show you more today is you've watched the tutorial, you understand how the software works. Now let's put it on the ShopBot and flip it and cut it and make sure it lines up. We'll also need to add tabs to this propeller to keep the part, one, from vibrating during the cut and affecting the edge quality, and two, just from falling out as we cut through it. So I've included a tab in the file that you can download for this. You could create your own, but what I'm going to do with this is I'm just going to place this tab, and instead of making 6 new tabs, I can just hold Control on my keyboard, and that allows me to drag a tab and drop it. And I like to just do one by one and place them. And the key to this being a very thin propeller, I really don't want to take any chance of the whole the thing vibrating. So I'm going to go ahead and manually just put my 6 tabs in place. So here's your tabs up here underneath the component tab, and you can click on it and you can see the shape height. So if you want to increase tab size, obviously you can grab the tab here and you can stretch it in width, which also changes the height because it's proportional, being 3D. And again, that's where you can change all the tab sizes if you want. And what I'm going to do is select all 6 of my tabs, and what I need to do with these is right click and I need to go copy to the other side because I want these 3D tabs to be on the front and the back side of this. So when I hit copy to other side, it now puts the tabs on the other side. So when I switch between my 2 sides, I can see that the tabs are lined up on both sides. So with the tabs in place, I can maximize my 3D view, and what's nice about the software here is I can hit the equal sign, or I can toggle between by clicking on this icon, and it toggles and it shows me how big my actual tabs would be being on both sides. So I can see I have a pretty good tab, and I could sit here now and mess with heights and whatnot and get the tabs centered in here. But again, use the Vectric tutorials that already exist for that. Let's go ahead and get this toolpath and set up for machining and flipping on the ShopBot. And to make it easy on ourselves, when we go to flip this, we need some alignment holes. So what's nice about that is circle command. I like to use 3/8 dowels, and these would just randomly put in. You don't need to symmetrically put these. If you do so, when you go to flip the thing, it'll be easier for you to accidentally flip it the wrong way. So be just randomly putting in those 4 holes. Those will be where my dowel locations get drilled into the material and into the spoil board for flipping. So let's maximize this here in the 2D view. And just remember, once you've got these 4 drawn, or however many it is that you put, whoops, I just want to select the dowels. And once you are done those, right click and just do a copy to other side. And when you do a copy to other side, when you do your flip, it shows you that it put them in the mirror direction that you have it oriented for your flip. So just keep that in mind. Again, all in the tutorials for the drawing software. Let's get into toolpathing and show you how this is done out on the machine. When you first switch to toolpath side, it will bring up your material setup, and the software allows you now to make sure your model is positioned in center. So if it's not, you can just double click on center. It moves you back in the middle. And just double check, if you don't have any clamps or anything for where your Z gaps are, home position. I like to move mine back a little. I have the room on my ShopBot, so when I'm done, you'll see in the video it goes back 10 inches, which goes out of my way, so it's not in my way when I'm ready to flip it or use the screw gun or change bits or whatever it may be. And then for me, again, what I was trying to say is when I don't have to change bits, that's great. So to get a finish on a propeller like this, I can get away with using a 1/4 inch ball nose. So I'm also going to use that ball nose for my dowel pins, which I'll just use a profile toolpath. Since it's an inch dowel, and I want to go half of it into my spoil board and half of it into my material. Being that it's a ball nose, I just want to cut a little bit deeper into the material and the spoil board, so I'll just go a little bit deeper with my 1/4 inch ball nose. The top side, I'm a little bit more aggressive with my cuts because there's still a lot of material left. So I'm going to go 5/8 deep with my 1/4 inch ball nose, and I'm going to go ahead and just add a spiral ramp to those 6 holes right there, and that'll be my top. I'm on my top side still for toolpathing this, and I want to call it that so I know what this is. This is a dowel hole. Let's see if I can spell here. Dowel hole for top of board. And I'm very clear on what this is called because when I get out there, I've got a lot going on with the flips and whatnot. So I've got an inside ramp cut, and I'm going to calculate that. And it's going to show me right here on the spoil board on the 3D, and there's my start back there. It comes in, cuts my 4, and there are my 4 cuts for the dowel holes. So that's just going to be the location. The next thing that we'll have to do is come in and do the roughing toolpath. So the roughing toolpath is this one here, and I'm going to use that same bit. Again, I'm just saving myself a bit change is all. It's just a personal preference. And I want to do this one again. I'm going to reference the tutorial from Vectric, and I like to do selected level, and I like to do it from my model level. And the boundary offset needs to be equal to whatever your tool diameter is. So I'm going to use a 1/4 inch bit. I have a boundary offset of a 1/4 inch. And then machining allowance is how much material do you want the roughing to leave on top of the finished cut. So 30 or 40 thousandths is fine. And again, instead of just 3D roughing, I'm going to call this 3D roughing top side so I know which one it is. And I calculate that, and it starts bringing this one in. And I'll finally finish that up by doing a finishing toolpath, same bit, selected level, model, because I'm bringing that off the model from back here on the drawing side. And the boundary offset needs to be the same as your tool diameter. And then it's a personal preference if you like to do an offset or a raster. Personally, I like to raster back and forth with the grain. I usually get a lot better edge quality cut. And then again, a name that makes sense. Top. So I have calculate. And now you can see that I've got my top side calculated. And I can preview all those tool paths, roughing, finishing. You can see the tabs around there. I left some pretty big tabs because I want you to see them in the video, and I don't want to take any chance of them falling out for this. So there is our cut for this. So there's our holes, our roughing, and our finishing. And let's take a look at that out on the ShopBot. So what's nice about the way we set this up is it's using the same bit for all the different tool paths. So first is drilling our indexing holes, which we'll use the 3/8 dowels for. So it's doing those first, and then it's going to do the roughing tool path and the finishing tool path. And we just used the 1/4 inch ball nose to use all three. So remember, I cut a little bit deeper for the indexing pin holes that make up for the ball nose at the bottom, get around the cusping part of that. Now we're doing the roughing tool path. So we're roughing it out at a heavier, faster speed. And again, we're all on the first top face right now, so it's nothing more than just a regular 3D carving that we've done before. I got the dust collection on just to show you that, it's good to keep the dust collector on. It does a lot of good for you, dust in the shop and breathing and all that. So leave the dust collector on whenever you can. A lot of times in the video I take it off just so you can see what's going on. When it gets done with the roughing tool path, now it's going to go back and forth and do the finishing tool path. So the finishing tool path, again, same bit up on top, the 1/4 inch ball nose, and this is going to work itself back and forth, and we set it up in the drawing software to go back and forth with the grain. So we can see that go back and forth, and this will finish up the top side of the cut for our propeller. Alright, once the top side's done, before we even pull it off, I want to go back to the software and make sure we get our files right. So this is what we're looking at so far for our cut. We can see the tabs were cut from the top side. Again, I can flip over right here, toggle to the bottom, and I don't have toolpaths yet for the bottom. So what I want to do for the bottom toolpath now is I do need to have my 2D view open so I can see where my layout holes need to be. And what we're going to do now that you see that we have switched it from the top view to the bottom view, notice when I toggle between the two, look over here on your right hand side where your material setup is. And notice that our first time when we make our face cut on the first side, it was to the top of the surface. And when we set up our job, it flips over, and now we're zeroing to our machine bed. So you need to make sure as the operator of your CNC machine that you are doing what the software is doing as well. So now that it is at the material bottom, which is your spoil board surface, you need to make sure that's what you do, and you'll see that in the video as soon as we're done tool pathing. So same thing that we did before, we need to grab our 4 holes, and remember that they are now mirrored, and notice the way we've mirrored them over, so that we also have to make sure we flip our board. You'll see that in the video. And again, same toolpath. I'm not going to change any settings on that. I'm going to add my ramp so it spirals down in. I'm going to use the same ball nose. And again, I want to name things so I know what they are. It's a lot easier to have a name when I get out to the machine and I know what they are. And I'm going to call these my spoil board layout holes. Calculate, and then there they are. And again, we're just walking through the same process. The only thing I would recommend you do, now that we're on the bottom, this propeller, again, if we can look at this in the 3D view, is a small, thin 3D model. And it's only got these 6 tabs that are holding it in place. So what I would recommend that you guys do for this one, on the bottom side now, since we've already cut away the top, and we're going to start exposing the through cut very soon here on our through roughing tool path, is, you know, same tool, same process, same tool path, same bits, but what I would recommend we do now is slow things down a little bit, and maybe instead of having such a deep pass as we did on the first side, I'm going to take, even though it's a 1/4 inch bit, I'm going to slow this down to a 1/8 of an inch pass depth and a slower 2-inch feed rate. So it may take a little bit longer to cut, and that's fine, but doing so, I know that it's not going to vibrate. It's going to give me chatter marks. I'm going to be able to avoid all that stuff by slowing this down and doing this with a little bit slower. So I'm going to call this 3D roughing, and I can call this second side. So I know what this is, and I have to make sure it's warning me that I forgot to grab what I'm supposed to have grabbed, which was up here underneath the selected level. I wanted to make sure I grabbed my model, and that way it's now just in the model and not the whole blank. And same thing here with the finishing toolpath on the bottom side, and we'll just same bit, same everything, grab my model, and I don't need to slow it down on the finishing toolpath because the finishing toolpath is just doing a thin cleanup around, and I'll name this one as well. And now that you can see, I now have different names, so it's nice to have a nice consistent one. So to change a name, I just wanted to show that you could double click on it, and instead of that saying bottom, I can call this second face. And now when I hit calculate, things line up. So I show that I'm on the second side. I've slowed it down. It's going to take a little bit longer to cut, but let's see what it looks like here in the video when I go and save this out. And you can see I'm cutting it now, flipping it, and cutting the second side. Alright, what we're looking at here is the first cut. We can see what it looks like before we flip it over. We're down, we cut a little bit past. Remember, we did a 1/4 inch overcut. I'm marking my top just so I know which direction I had this. Take my screws out, and since we already did our dowel pin holes in the top of this board, we need to just push it straight back. We don't want to take this thing out of orientation and confuse ourselves any more than we have to, especially when we're first doing this. And remember, we just looked in the software now where when we flip it over, we're now zeroing to the spoil board. So I'm setting up my Z0 plate, and I'm now just going to do the same routine I would normally do in my ShopBot software and zero my Z off the bottom. And then the first toolpath that I'll run is the 5/8 deep dowel pin locations, which is my 3/8 dowels. So I had those 4 holes. They're going down into the spoil board, and I did lay those out in a fashion so they would not drill into the desktop hold down method, and we can see that back in the drawing file when we go back to that. So I'll move that out of the way, and then I will have to move my Z up so I can push my board forward, blow the air out of the sawdust out of those holes, put your dowel pins in place. And now it's, remember, the way we set the file up is just to flip it back over in the Y. So we're just doing a 180-degree flip over back onto its second face. So make sure you flip it the way you designed it. If you've designed it the other way in the software, just flip it 180 degrees lengthwise. But this is the way we flipped it in the CAD. So we flip it over, we run our screws in place, and now we're ready to run the second face. So this is why it's nice to have our zero of our X and Y plane right off the middle. Everything is all off that zero plane off the middle. So it doesn't matter if our board isn't quite the right width the way we set up the file. It's all going to line up doing it this method. And let's take a look at that next. Alright, we flipped it over now to the back side. And we'll start our roughing toolpath. And just notice that this side, we've turned down our feeds and speeds a little bit. We're not trying to set any records here for winning a race. What we're trying to do is get in and rough out this, because we're soon going to expose through. You can already see around the edges that we've already exposed to the second side. So I've only got those 6 tabs that are holding it in place. So you can see that I've got it a little bit slower, and that's why those, I can use smaller tabs, so make it take a little bit longer to machine, but less time for cleaning up tabs. And without the dust foot on, it does make a big mess, and it is pine. It's a little stringy on the long cuts, but we can see that we're able to get down inside there. Now it's switched from our roughing to our finishing tool path, and now it's going to start finishing back and forth. And again, I set it up just personal preference to go back and forth with the grain, and that's all something that you can set up in the drawing software, in the Vetrix software. You can set that up to go back and forth the way you want. You can see just a little bit of flex right there. That's why anything bigger than this would need a little bit bigger of a tab. And now we can look, before we unscrew anything, we want to make sure we're through, we're lined up. If I need to make any adjustments, because once I unbolt this, I can put it back in place because it is using the dowel pins, but it's always good to make sure before you unscrew it. And I'm going to pull this off here now and look, and it's great. It worked out great. I was able to flip this over and cut from 2 sides, and it's held in there tight with those 4 dowel pins. And I was able to take a propeller, scale it to my board, and it was just nice cutting it out of some 2x6 material to test it with. Put some tabs in place to hold it there. Do a little bit of overcut, so you cut past the face that you want to cut into, and then you're able to successfully cut a double-sided 3D file. And this one just needs some cleaning up, and use a bandsaw to do that. But try this method with some different 3D files that you have that need to be cut from 2 different sides, and you'll see that the lining up the way we set up this file works great. A 2-sided machining is definitely a big job to take on, especially if you're first getting started. So I would definitely recommend first looking through the help tutorial browsers to become familiar with the software. And when you're familiar with the software, some things to just remember to keep in mind when you're setting up your job. It is nice to be able to have this option here where you can zero off the same side. So when you do the flip, it goes from the front to the back. You just need to remember that when you're zeroing it out on your physical machine, out on your ShopBot. Alright, remember up here too, this is where you toggle between the top and the bottom. You can toggle between what face you're going to look at. The brown right here shows that it's at the bottom, and when I toggle this, the arrow shows you that I'm looking at the top. Alright, over here on the toolpath side, it's going to change the toolpath between when you toggle up and toggle down. So label things so you know what they are. Remember when we did our setup, whatever our, not this one, I'm sorry, whatever our bit diameter was is what we also used for our boundary offset. That was what allows you to get around the 3D file. Remember back in the modeling tab where we had underneath our limit planes, and we were able to go in here, and this is where we could see our base height, and then we had a -1/4 inch, and that's what showed us what our overcut was, so we could get around the cusping as far as using that ball nose. And again, it was just a personal preference here on why when I saved this out that it used the ball nose, just so we didn't have to do a bit change. So today's training was just giving you some tips and tricks and helpful setup and layout for doing a 2-sided 3D carving. So it's really going to take a little bit of practice until you've done it once or twice. And once you do it, it's really an awesome process. So for other trainings, you can always check out the tutorial browser. That's going to help you get through all the different Vectric tutorials. But I also just want to point out shopbottools.com. And on here you can see all of our different online trainings. You can sign up for our newsletter. You can read our forum. And you can see what's going on new with us. And you can always contact us if you have any technical support issues. We are here for you, and we are happy that you joined us today, and we look forward to our next training with you. Thanks, everybody.